Welcome to Session 11, Radical Equations and Extraneous Solutions. This lesson strengthens algebra that remains reliable when the numbers or representations become unfamiliar. You will learn to identify the real number domain of an even radical, to isolate a radical before squaring, and to remove extraneous candidates through original equation checks. Treat these as connected habits. Keep a pencil ready. We will build a visual model, use a repeatable process, solve a demanding example, diagnose an error, and finish with a checkpoint. Start with this picture. A candidate must survive algebra, domain, and original equation checks. Squaring may widen the candidate set, but the original radical and sign conditions narrow it again. Only candidates passing every gate belong to the solution set. The gate distinction is this. Identify the real number domain of an even radical. Then connect it to the second goal. Isolate a radical before squaring. Correct methods begin with correct interpretation. When a problem looks different, look for the same mathematical structure instead of an identical example. That transfer makes the skill durable. Step 1. Record radicand and sign restrictions. Identify the object being changed and the requested result. Step 2. Isolate one radical before squaring both sides. Use a separate line so signs, units, and restrictions stay visible. Step 3. Solve the resulting equation and repeat carefully if another radical remains. Work efficiently without skipping an operation. Step 4. Substitute every candidate into the unsquared original equation. Whenever possible, verify with evidence independent of the original working. Signal 1 is even root. Respond by remembering. Require a non-negative radicand. Name the response before calculating. Signal 2 is radical equals an expression. In that case, that expression may also need to be non-negative. The form tells you which tool fits. Signal 3 is equation was squared. Remember, expect possible extraneous roots. This separates plausible from valid answers. If you cannot name the signal, slow down. Deliberate classification is faster than repairing rushed algebra. Here is the challenge. Solve the square root of 2x plus 3 equals x. Restate the target and identify the most important part of the routine. The first move is, the right side requires x greater than or equal to 0. This changes the form without changing the meaning. Next, square. 2x plus 3 equals x squared, so x squared minus 2x minus 3 equals 0. Keep the relationship visible and apply the operation to every required term. Now audit distribution, signs, copied values, and restrictions. A brief midpoint check is cheaper than rebuilding the solution. Continue with the third step. Factor x minus 3, x plus 1, equals 0, giving 3 and minus 1. State what the transformed line tells you. Complete the argument. Only x equals 3 satisfies the domain and original equation. This is part of the solution, not decoration. The final answer is x equals 3. Compare it with the requested variable, expression, unit, interval, or classification. Verify from another direction. Substitute, compare representations, inspect units, or test a boundary. Prove that the result satisfies the original conditions. Try this checkpoint without copying the example. What restriction comes from the square root of 5x minus 10? Decide which mathematical fact controls the answer. Write one line of reasoning before you commit. A visible decision is easier to inspect and correct. Focused hint. Require the radicand to be non-negative. Use it to repair your setup rather than guess. An accepted answer is x greater than or equal to 2. Explain why it works and name the first step that would expose a common error. The central message is, identify the real number domain of an even radical. Combine it with the discipline to isolate a radical before squaring. Finish by remembering to remove extraneous candidates through original equation checks. This turns a calculated result into a justified answer. Reflection. Which operation creates the risk of extraneous roots, and why? Name the error specifically so you can interrupt it next time. Practice one fresh problem within 5 minutes, including original equation checks. Keep the work readable, check it independently, and carry the routine forward.